So, one thing that we've spent some time doing is solving an a system of equations, and that is a problem where you've got two different equations and you want to find the value where they are equal. And so far, the way that we have solved these is by graphing. And what I want to show you right now is how to solve them without graphing. So let's read the problem. It says Andy's rental car charges an initial fee of $20 plus an additional $30 per day to rent a car. Buddy's rental car charges an initial fee of $36 plus an additional $28 per day. For what number of days is the total cost charged by the companies the same? So our two equations are going to be one for Andy's rental car. So we've got to write an equation for that guy, Andy, and his rental car company. And then we need to do a second equation for Buddy's rental car. Just based on name alone, I think I've got to go with Buddy's rental car. It sounds so friendly. I'd like to rent from Buddy's rental car, but we'll do the math and see which one's going to be the cheapest. Okay, so before we do any kind of word problem, the first thing we want to do is define our variables. So let's come over to the side and define our variables. Now, it looks like the two things we're measuring, the thing, number one, that the problem wants to know is what number of days. And then the other thing is the total cost. Okay, so let's make those our variables. Now, when I read through the problem, it says that Andy's, for example, has an initial fee of $20 and then $30 per day. $30 per day and the initial fee are telling me the slope and the y-intercept. The initial fee, as we've learned, is always the y-intercept, so that's going to be our b. And $30 per day is going to be the m. And because the m is per day, that tells me the x is going to be the number of days because it's going to be 30 times X. So $30 times the number of days. So that tells me I'm going to use X for number of days and I'm going to use Y for the total cost in dollars. Now, because I'm not going to graph this, I actually don't need to use X and Y. I could use whatever I want to. I'm going to use X and Y because I'm going to write this in slope intercept form, but I could use D for days and C for cost, and it'd be totally fine. And I will do that on future problems. I'll use stuff besides X and Y, but just for this first one, because we're going to be writing it in slope intercept form, we'll go ahead and use X and Y just till we get used to it. So Andy's is going to be written in slope intercept form, y equals mx plus b. And we said m is going to be the 30, and b is going to be the $20 initial fee. We've done this a million times. We should know y equals mx plus b has the initial fee as b, and the increasing cost or the rate of change is m. So then Buddy has an initial fee of 36, so that's going to be the b for that one. And an additional $28 per day, that's going to be the M. So Y equals 28x plus 36 for Buddy. Okay. Now, up until now, the only way that I've shown you how to solve these is by graphing the two and seeing where they cross. In this case, the problem wants to know the number of days, so we would see where they intersect and find the value of x. But there's another way you can do it without graphing, and that is a little bit faster sometimes. It's definitely going to be faster in this case. And the way that we do it is by first noticing that both of these equations for Buddy and Andy equal y. Both of these equations, 30x plus 20 and 28x plus 36, equal the same thing. They both equal y. They equal the same thing. And if they equal the same thing, that means they are equal to each other. If they both equal y, that means they equal each other. So 30x plus 20 and 28x plus 36 equal each other because they both equal y. So one of the ways that we can solve for x is by taking Andy's rental car equation, 30x plus 20, and setting it equal to Buddy's rental car equation, 28x plus 36. And you'll notice that once we do this, we don't have a y variable anymore. We only have x. And so our goal now is pretty simple. What is the value of x? So how is this problem different from any other equation that we've done all year long? And the difference is that now we have a variable on both sides of the equation. Now, I don't know if you've dealt with this before in any of your mathematics classes, but I know you haven't dealt with it in this particular course we've been going through, where we have variables on both sides of the equation. When you have variables on both sides of the equation like this, our goal is get your variables on one side. And in this problem, there are two different ways you can do this. We've got a variable of 30x on the left side, and we've got a variable of 28x on the right side. So one thing we could do is we could subtract 30x on both sides of this equation. Subtracting 30x on both sides will cancel the x's here and leave us with only x's on the right side of the equation. That would get all of our variables on one side. The other way we could do it, you can probably see it, is subtract 28x on both sides. And this would do the opposite. This would eliminate the variables on the right side and leave us only with variables on the left side, which also accomplishes our goal of getting our variables on one side. And both of these will cause us to get the same answer, so we can do either one we want to. So, if we're in a situation where both will work and we can choose whichever one we want to choose the one that is easiest. Even if it's just slightly easier, why not pick the one that is very slightly easier? So, which one is going to be easier, subtracting 30x on both sides or subtracting 28x on both sides? Which one of those is going to have math that is a little bit easier? The answer is subtracting 28x on both sides. And the reason that subtracting 28x on both sides is going to be a little bit easier is because when we eliminate the 28x on this side and have only x's on the right side, we'll end up with a positive 2x. If we subtracted 30x on both sides, we would, of course, as I said, still end up with the correct answer overall, but we would have a negative x on the right side. There's nothing wrong with the negative x. We could still solve the problem with the negative x, but negatives are very, very, very slightly more challenging than positives. So why make it more challenging for ourselves if we can avoid it? So now it's a very simple two-step equation. We've been doing these forever. Let's subtract 20 on both sides to eliminate that positive 20. Okay, that will give us 2x equals 16. And then, of course, the last thing we need to do is divide by 2. And 16 divided by 2 is 8. So the value of x is 8, but we certainly do not want to stop and say the answer is 8. We want to answer the question in context. The question was, for what number of days is the total cost charged the same? 8 is the number of days, so we will say at 8 days. We don't say after 8 days, because it's not after 8 days, it's at 8 days. The total cost of the two companies is the same. Now, if we really wanted to impress the teacher, and who doesn't want to impress the teacher, we could figure out what that cost is. Let's go back to our Andy's rental car, 30x plus 20, and let's replace the x with 8. After 8 days, what does it cost? We could just plug this into the calculator real quick. 30 times 8 is 240 plus 20 equals 260. That cost is $260. The problem didn't ask us for the total cost, but why not go the extra mile and answer the question that wasn't even asked? After 8 days, both companies will cost $260. Now, if you're wondering, hey, wait, don't we need to also go plug in 8 for Buddy's rental car and see how much it costs after 8 days? The answer is no, of course not, because after 8 days, the cost is going to be the same. If we went to Buddy's rental car and plugged in 8 for X, we know we're going to get $260 because we just said that the cost for Buddy's rental car and Andy's rental car is the same. So again, we would go to the calculator. 28 times 8 is going to be 224. And 224 plus 36, hey, what do you know? 260. It's the same because, of course, it is. We just proved the cost is the same after 8 days. So the problem only wanted to know how many days, but because we are go-getters, we are tryhards, as the kids say, we went the extra mile and said, not only do we know that they're the same after 8 days, here's how much it costs after 8 days.